So this is exercise which is related to organic synthesis and arenes. Organic synthesis, you will learn different methods to change compound from one to another. Question 1, ketones are useful starting compounds in organic synthesis. This question is about butanol. The mass spectrum of butanol has a significant peak at 43 and 57. Give the structure of these peaks. So how you can work out? See, 12 plus 3, 15 is there. 12 plus 16 makes 28. And this will be 14 and this will be 15. You can read from left to right and right to left to work. So we need 53. So 15 plus 28. So that will be 53. Sorry, 43. Sorry, not 53. Don't forget to write the chart. So this will be 43. And what about 57? So if you add CH2 or like this also 15, 14 and 28 will also be 29, and this will make, like if you read from, even I add this one, like if I have H3, C double bonded with O and CH2, that will also give us a peak because 43 plus 14 will make 57. So this will be another peak as well. Or you can break from other site as it will give the same idea. Give the structure of one other species that you expect to produce a peak of a different MZ value in the butanol. So another peak which we expect, like this was 53, 20, 15. 15 is also there. You can mention any of them. You can mention like 15, you can mention, or you can mention 29 as well. And that will be CH2, CH3, any, because acceptable multiple are there, not the molecular ion peak. Devise a reaction scheme to prepare propane 1-ol from butanol using no more than 4 steps. Identify the reagents and essential condition for each step. Look, first, as you can see, prop means 3 carbon and but means 4 carbon. So what we have to do? We have to reduce the carbon number as well here, like butanol to propanol, propane 1-ol. So definitely reduction must be done, and we have to reduce the number of the carbon as well. So first, what we do, we will react this butanol with the iodine. That is also the iodoform reaction. Like we have butanol is given here, the structure of butanol. So this is butanol. And when we react with sodium hydroxide and iodine, like first it's a iodoform reaction when a methyl group is there next to carbonyl group. So we react with sodium hydroxide and iodine, which is actually the iodoform reaction. So what it will form? It will form sodium propanoate, because like this part will break and it will form CI3H triiodomethane plus it will form NaO, then C double bonded with O, CH2, CH3. This is what is formed. So it will form sodium propanoate, like this is a sodium propanoate, and iodoform is triiodomethane is also formed in alkaline solution. Then what we do? We add propanoic acid sorry, we add an acid to convert because we want to replace this metal with a hydrogen. So what we do, we add acid. Any acid as can be added here, sulfuric or hydrochloric acid. As a result, it will form a propanoic acid, like HOC double bonded with O, CH2 and CH3. So this will turn into propanoic acid. And this propanoic acid, we use lithium tetrahydrodualuminate. So lithium tetrahydrodualuminate, LiAlH4 is there. Reduction will happen, and this reduction will convert this into alcohol. So CH2, CH3, C, H2 and OH will be there. So this will turn into propanol. And this should be in a dry ether. So not more than four steps. So first step, what we did, we use the iodoform reaction to remove one of the carbon from the chain, and then we add acid to convert into a carboxylic acid, and then we do a reduction. It will turn into alcohol. I have shared all the reaction schemes in which both for arenes and as well aliphatic compounds. You should go through them, as they can ask an exam to prepare different compounds from different starting reagents. Another one, devise a reaction scheme, prepare 2-methyl butene from butanol. Use not more than 4 steps. Identify the reagent, essential conditions. So here, ketone we have to convert into alkene. Okay. So we have initially butanol is there. And again, we cannot use more than 4 steps. So we have CH3, C double bonded with O, CH2, CH3. This is a butanol. And we want this, our final product, we want butene. To methyl. So second position, methyl group is there. This will be CH, and this is what we want. That's the final product. So first, what we can do, we can convert this into any suitable product. As we have butanol is there. So the suitable halogen alkane we use, like we can use example methyl bromomethyl or methyl bromomethyl is there, bromomethane is there, or a chloromethane is there. Actually, it's like making that into a Grignard reagent. So first example, we add and then it will turn into a Grignard reagent. Plus the magnesium is also added, magnesium powder. So adding like example a bromomethane or a chloromethane and a magnesium powder. And the condition to add this, that is in a dry ether. And this will result in a formation of a Grignard reagent. What is the Grignard reagents? Grignard reagent means like it will have a magnesium is there, one side is halogen, another side is alkyl group. That is a Grignard reagent. Like the first thing is forming a Grignard reagent, and then this Grignard reagent, it's like because what we want to add a branch here. Okay, like we want, whenever we want to add a branch, that branch what we need, like example, if I need CH3 branch, then I will use a bromomethane. If I need like ethyl branch, then bromoethane. So first is only this part is, instead of reacting this one, first is only this part producing a Grignard reagent. After producing this Grignard reagent, this we will react with a like now this will react with a Grignard reagent, which is methyl group is there, CH3, Mg and Br. And as a result, what will happen? So that group will be added. Sorry. This will form 2-methyl butane 2-ol. It will turn into alcohol. CH3 is there, CH2 and CH3. So because we use a dry ether is there, like this is being reduced because it convert into secondary alcohol, and because of the presence of the Grignard reagent, the branch is also added. Now we want the elimination reaction to happen because we want to convert this alcohol into alkene, like butene is there. So for elimination reaction, if you want the elimination reaction to happen or occur, as OH and H we want to remove, and we want to convert this into CH3, double bond, CH will be there, and then CH3. So we can use like first dry ether is there, reduce, and it will form with a Grignard reagent. When it is reacted with, it will form 2-methyl butane 2-ol. And after this, we want a elimination reaction. So for this elimination reaction, we can use any acidic condition. Like we can react with sulfuric acid. As a result, what will happen? Elimination reaction will occur, and it will produce NH and OH, and it will form but2, like it will form 2-methyl but2e. So whenever you want to add a branch, we always prefer to use a Grignard reagent. Is it clear? This one? In question two, using an access, yeah, butanol, ketone is, no, not tertiary, ketone will also always form secondary alcohol. Like here, whenever a reduction happens for a ketone, it will form a secondary alcohol, like CH3, C double bonded with O, CH2 and CH3. When we do a reduction, it will form CH3, COH will be there, H will be there, CH2 and then CH3. When we use a Grignard reagent, CH3, Mg and Br is there, or halogen. So one of them will be attached to the group where there is a OH available, like a branch is there. So as a result, it will form CH3, OH will be there, The CH3 will be there, CH2, and then CH, and then we carry out a reduction. So first it will form a secondary, and then the secondary alcohol will convert into a tertiary by using a Grignard reagent. That is what is done. Using excess of oxygen, 25 cm cube of a hydrocarbon completely burned after cooling to a room temperature, 75 cm cube less than the total volume. Determine the molecular formula of compound. You must show your working. Like the total reduction in the volume is 75. Like the reactant minus product, that total volume is equals to 75. So the total volume and 25 cm cube. So this is 25. This will be 25 times, as the ratio is 25 cm burned completely. And after cooling, the temperature total volume of a gas was measured, which is 25 cm cube less than the before the mixture was ignited. When the product of a gas was shaken with potassium hydroxide, the total volume further decreases by 100. So sodium hydroxide will react with the unreacted, means the formed carbon dioxide. So this gives us, if this is 25, this will be 25 times this will be 25x, and this will be 25 y by 2 H2O. If it was a water vapor, because the volume ratio and the mole ratio is always same. So 100 cm cube, the volume reduces 100 cm cube because carbon dioxide will react with potassium hydroxide. So what is the volume of a carbon dioxide? If 25x has a volume of, if 25x has a volume of 100, because it reduced, so x will be 100 divided by 25, so x is equals to 4. So the value of x will get 4. And the total reduction in the volume when reactant minus product volume, like this is 25, this will be 25 times x plus y by 4 minus, because the water is, it is cooled to a room temperature, so water will be a liquid. So this will be the total volume of a gas. So the product is 25x, and that will be equals to how much? 75. And the value of x we already worked out, it is 4. So when we simplify this equation by substituting x is equals to 4, we'll get the value of a y is equals to 8. So x is equals to 4 and y is equals to 8. So means this is butene. And x and y was added into a little of bromine, and the bromine stayed yellow, which give an idea it is C4NH8. So it is not butene, it is not an alkene. It is an isomer of alkene, which is a cyclic alkane. So we have to draw a cyclic alkane. The possible structure, two possible structures, so CH2, 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 and CH2. This is one. And another possible structure, CH2, CH2, PH, and then CH3. Because the bromine it does not decolorize bromine, so this gives an idea it is a cyclic alkane rather than alkene. Is it clear? Question 2, how we worked out the volume? Because it was room temperature, that's why we did not take the water. So the total reactant minus the product, the volume was 75, the difference. And 100 cm cube of potassium hydroxide, which was only reacting with carbon dioxide. So 25x, because this was 25, so this is 25, this is also 25. So 25x was 100, so x is equals to 4. So this was organic synthesis and Arenes. Any question or a doubt related to the session today?